we are looking at more inferences and more hypothesis testing, but this time we are looking at two samples. So we're going to start with two proportions. We are looking at two proportions. Sample proportions are from two simple random samples. SRS samples are independent if the sample values selected from one population are not related to or somehow naturally paired or matched with the sample values from other populations. We discuss the matched pairs with more details later. And again, remember NP and NQ must be large. Now in this case, NP hat and NQ hat must be large. Synopsis: testing a claim made about two population proportions. We're going to construct a confidence interval of the difference between the two population proportions. And remember, when we talk about proportions, it may be in the form of probabilities, decimal, or even fraction. And the objective is the hypothesis test, conduct a hypothesis test of a claim about two population proportions. Also, confidence interval, construct a confidence interval, estimate of the difference between two population proportions. That's what we are going to do in this section. So for the populations 1 and 2, remember P hat was X over N. Now P1 hat is X1 over N. Remember Q was minus P, Q hat was 1 minus P hat. So it makes sense to say Q1 hat is 1 minus P1 hat. Same thing goes for P2 hat, X2 over N2, Q2 hat is 1 minus P2 hat. So whatever we have learned for one sample, it works for two. And to distinguish between the two, we give them a subscript. Subscript 1 for the first one, subscript 2 for the second one. And so the pooled sample proportion combines the two samples proportions into one proportion and test the statistic. What do we mean by that? In the case of two proportions, the formula that we are going to use, P bar is X sub 1 plus X sub 2 over N sub 1 plus N sub 2, or simply if P1 hat and P2 hat are given, add them up, divide by 2. That's the same concept. Now Q bar is 1 minus P bar. Okay, this is known as the pooled sample proportion. And for test statistic, we use that one. So take a look at the formula. Z is P1 hat minus P2 hat minus the parentheses P1 minus P2 over. Now, the way you write the denominator, if you write it in the same format, look at the first one versus the second one. If we factor out the P bar, Q bar from the second one, from here, we get to this one. In other words, I'm showing you these two are identical, okay? So P bar, Q bar over N1 plus P bar, Q bar over N2 is the same as P bar, Q bar times 1 over N1 plus 1 over N2. So depending on the text, if you come across one or the other, you don't want to get confused. Let me give you the confidence interval. I will show you the comparison. As far as the confidence interval is concerned, P1 hat minus P2 hat plus minus E equals Z alpha over 2 times sigma of P1 hat minus P2 hat. If you look at the confidence interval, see the similarities between one and two samples. Needless to say, this is a little bit more complicated. I want to remind you of what happened when we dealt with one sample. The confidence interval was P hat plus minus. Now the confidence interval is P1 hat minus P2 hat plus minus. In this case, test statistic Z was P hat minus P over the square root of PQ over N. You see how similar they are. Now in this case, is P1 hat minus P2 hat, and so on and so forth. So the thing I want to add is, as far as the formulas are concerned, the formulas may be more complicated, and they are. However, you have access to them. All you have to do, look up your formulation. Now, the other thing that I want to add here is extremely important when you want to calculate your test statistic, and that is the following. When we look at P1 minus P2, this one. So when you're looking at this part, this will go to 0 because it comes from H0. It comes from non-hypothesis. So that is always 0 for us. However, if you're doing a research and for some reason you're interested in a situation to have a difference of specifically, let's say, a 0.2, then it's no longer 0. But as far as we are concerned, it is 0. All right. Let's start with some example to see how it goes. And by the way, because this denominator uses P bar and Q bar versus this portion which is used for E that uses P1 hat and Q1 hat, this is the reason if you look at the bottom line, the p-value method and the critical value method are equivalent, but the confidence interval is not equivalent to them, because in some instances it may not give us the same result simply because we are not using the same formulas. In fact, the same as proportion. If you recall, in that case, E was Z alpha over 2 square root of P hat Q hat over N. All right. So now, here's an example.
A survey of 1,000 drivers this year showed that 29% of the people send text messages while driving. Last year, a survey of 1,000 drivers showed that 17% of those send text messages while driving. At alpha equals 0.01, test the claim that there has been an increase in the number of drivers who text while driving.
Let's go through the same process. Look at the bottom left. Again, we are repeating the same steps when it comes to the test of hypothesis. That's as far as the steps. The other one is writing the information. The given is obviously we are dealing with the binomial distribution. Alpha is 0.01. Now n sub 1, we are dealing with two different groups. By the way, if your choice of n sub 1 is the other one is fine. N sub 1 is 1,000. P1 hat is 0.29. N sub 2 is 1,000. And P2 hat is 0.17. So two different samples. Starting with the first step, H0, we go with the equality. So in the case of one sample, we would write H0 P equals a number. Now P1 equals P2. And what are we testing? Testing that there has been an increase. So, okay, P1 is larger than P2. So there has been an increase. That means larger. That means right tail test. We are testing this claim. You see the similarities. We are repeating the same concept. The test statistic is much more interesting. So if you look at the top right, the formula for test statistic is given. And as I mentioned, P1 minus P2 is coming from H0, and therefore it is 0. I put both formulas. Again, it depends on the text. One may use the top one or the next one. They are identical. As you look at the formula, we need to come up with P bar, x sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. By the way, as you can see, x sub 1 and x sub 2 are not given, so you simply multiply by P hat. Okay, in this case, 1,000 times 0.29 and 1,000 times 0.17, and you divide by the sum. This is how you calculate it if x is missing. If x is missing, that's how we calculate it. By the way, in this case, if you added up P1 hat and P2 hat and divided by 2, you would get to the same answer. However, the reason why, because N1 is equal to N2 equals 1,000. So let me make sure we understand what's going on here. The reason they end up being the same because they have the same sample size. Otherwise, they won't. Because in essence, you're doing the weighted average. I repeat, N1 is equal to N2, therefore, you could just add them up, divide by 2. Now we are ready to come up with the test statistic. We look at the formula at top. So P1 hat, 0.29 minus P2 hat minus 0.17. And then we write the square root of P bar Q bar 0.23 times 0.77 over 1000 plus the same thing over 1000. That's the square root. So as you can see, it's a complicated formula, but you don't have anything to worry about because you have it in your formula sheet and it gives you the answer. So now, just as before, what do we do next? We take the step that we do always, and that is go with the critical value and see what happens next. The critical value comes from the choice of alpha. Alpha is 0.01, and this is a right tail test. So you get positive 2.33 or really 2.325, because if you go to the table, and by now I hope everybody is comfortable with the table, it's somewhere in between. And all you have to do the drawing. You have the graph and you want to see the location of test statistic compared to your critical value. As you can see, the test statistic is way into the rejection region, the tail. Therefore, you reject H0. All you do is just follow the calculation. Now we elaborate. So what does it mean? If we are rejecting H0, now we're going to go look at the very first step that we wrote for H0 and H1 and see the location of the claim. If H0 is rejected, then H1 is not. Again, loosely put, therefore the claim is not rejected, therefore the claim becomes true. And then you do the writing. There is sufficient evidence to support the claim that and you just follow that. So reject H0, therefore the claim becomes true. So there is enough evidence to say that the proportion of drivers who send text messages is larger today than it was last year. CV method is short for critical value method, also known as standard method or traditional method.
Proportions of cars with rear license plates only. Are the proportions the same in Connecticut and New York? Use a 0.05 significance level to test the claim that Connecticut and New York have the same proportion of cars with rear license plates only.
Clearly, the question is indicating proportion. We normally have to write the given, pretty much it's given to us, and it is a binomial distribution. By the way, even with the previous one, we didn't really check. It's really a good practice to check this stuff. By that, I mean checking that N1P1 hat, N1Q1 hat, also N2P2 hat and N2Q2 hat are large before you move on. Normally, the questions we deal with, those are met. So having said that, obviously you can see from the table. By the way, in some text, instead of saying that, they may use like X sub, let's say C for Connecticut and X sub N for New York, or they actually spell it out. That's fine. Depending on the text, we can have different notations. As long as we understand what we are doing, we are in good shape. So that being the case, X sub 1, N sub 1, X sub 2, N sub 2, alpha, all of the above are known. And so we're going to move on and we're going to come up with various steps. The very first step is H0 and H1. So obviously H0 P1 equals to P2. So we are using a 0.05 significance level to test the claim that have the same proportion. So see, it doesn't say less or more, so it's not equal to, and the equality is the claim. So with that being the case, we go to the second step.
Isn't the null hypothesis supposed to be what we're trying to reject?
No, we are just doing the test of hypothesis. Some texts, they specifically want to do that, but that's not what we are doing. If you look at this question, it says use a 0.05 significance level to test the claim that Connecticut and New York have the same proportion. Whether we reject it or not, after we go through the process, we are just trying to look at the claim and we do the process. We may reject it, we may not.
Right, because I understand that you don't necessarily have to reject the null hypothesis. Sorry, I worded it wrong. I meant, is our claim not always H1?
No, absolutely not. In some cases and in some texts, they make sure that it's always H1, not here.
Okay.
H0 or H1, any of them goes. In fact, if you go back to the previous chapter, a couple of occasions, H0 was the claim. I'm glad you asked. That's a very important question. In some texts, they make sure H1 is the claim. That's not the case here. And it doesn't have to be. And in fact, most authors have changed their opinion about that. And nowadays, claim can be any of it.
So in a real life application, we have to just state which, if H0 is our claim or H1 is our claim.
That's what they do nowadays. But remember, you're the researcher. You decide how you want to set up your research question. Okay, you can always set up your research question such that H1 becomes the claim, and that's what they did. They can still do the same thing, but it doesn't have to be.
Okay.
And there are some who are still more comfortable with that. By all means, stay with that. If you are the researcher, you are making the decision. So make sure your claim is H1. That's absolutely fine. That is your choice. But this is really not the case always. Sounds good?
Yes, thank you.
In order to come up with the test statistic, we need P bar and Q bar. So let's find P bar x sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. And then 1 minus that is Q. To do this, we need to calculate that first. Take a look at the one on the bottom left in green. And so we really have to do that first. We have to calculate P1 hat, 2 hat. We need those for the numerator of your test statistic. We need P1 hat and P2 hat for the numerator of test statistic. We need P bar and Q bar for the denominator of test statistic. So the stuff at the bottom left in green must be calculated first and foremost before we go to the test statistic. So after we do that, we plug in, we end up with 7.11. The next step is calculating, coming up with the critical value. It's not a calculation. It comes from the choice of alpha. Alpha is 0.05, and we are dealing with a two-tailed test. And again, that's a common value, 1.96, but its two-tailed test is plus minus that. We look at the location of test statistic when it comes to the graph containing the two values of critical value. Take a look. Now 7.11 is way into the rejection region on the right side. So what do? Clearly, from the graph, we are going to reject H0. Now the rest, parts B and C of the decision making, you just do the right. So again, the first part, all of this calculation results in rejecting H0. And if you are rejecting H0, then you're rejecting everything that comes with it. In essence, you're rejecting the claim. In essence, the claim is false.
Decision, reject H0. The claim is false. There is not sufficient evidence to support the claim that P1 equals P2. That is, there is sufficient evidence to conclude that Connecticut and New York have different proportions of cars with rear license plates only. It's reasonable to speculate that enforcement of the license plate laws is much stricter in New York than in Connecticut, and that is why Connecticut car owners are less likely to install the front license plate.
Again, if you were to use a TI, you use two proportion z-test. Click on Stat, Tests, two proportion z-test, and enter the data and choose whether it's right tail test, left tail test, and so on and so forth. And it gives you the result. Now, if you look at the result here, it gives you this p-value. We don't want to mix this up with the proportion. 1.19 times e to the power of negative 12. E negative 12 means times 10 to the power of negative 12. It's almost zero. P-value is extremely small. And I hope it makes sense, because what is the p-value equal to? The p-value for a right-tail test, in essence, discussing the next page, what is the p-value? The area to the right of test statistic, if it's a right-tail test. Because it's two-tail test, the same thing times 2. To the right of 7.11, you shade that and you multiply it by 2 because it's two-tail test. And you compare it to alpha. And clearly it's less than alpha of 0.05, and you get the same decision. Reject H0. We're going to do it by traditional method. It's already done by the p-value and confidence interval, and we've done the calculation. Take a look at the table at the top right. This is from the previous page. So we are looking at the same question. We are looking at the information on the bottom left. We have done the calculation for P1 hat, P2 hat, P bar, and Q bar. We have those. And now to find the p-value, we need to look at the area. So I want you to look at the area first. Area to the right of 7.11. So we are looking at this area. And why are we multiplying it by 2? Because it's a two-tail test. It's extremely small. If you look at the technology, it's almost zero. If you look at the table beyond specific, I think beyond 3.5, it goes with like 0.0001, which is times 2, 0.0002, which is clearly less than alpha of 0.05. Remember, the choice of alpha was 0.05. So the p-value is extremely small, and we reject the null hypothesis that P1 equals P2, and the rest of the writing, we had it in the previous page. We repeat the same writing. So this was the p-value method. Let's go with the confidence interval method. We have the same question. We are looking at the third case, confidence interval. The table was in previous pages. The given stuff here, we have it. And now we need to calculate the confidence interval. To do that, here's the formulas. We have P1 hat minus P2 hat plus minus E. E is Z alpha over 2 square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Now, it was a two-tail test, alpha of 5%. Because it's two-tail test, it corresponds to a confidence level of 95%. So we can find the confidence interval of 95%, which means Z is the same Z as the previous page, plus minus 1.96. So in this case, obviously, we use 1.96. Everything else in the formula E is calculated. P1 hat, Q1 hat, just plug in. And we end up with the following. So we calculate the value of E. So having said that, all we have to do now, add and subtract this when it comes to P1 hat minus P2 hat. What do? We finish this first. It gives us E of 0.017482. So P1 hat minus P2 hat. Now, one of the things I want to tell you, when you are doing the calculation on your own, you want to spare some time. You want to keep your calculations. If you go back to the previous page, the P1 hat minus P2 hat was the numerator of your test statistic. So in essence, you have that. I want you to know that. So with that being the case, P1 hat minus P2 hat plus minus, we just have calculated the value of E is 0.017482. Now, it's really good practice to keep it like that. A few decimals would be helpful. At some point, we do the rounding, but it's good to have it to begin. So having said that, we end up with the following. Therefore, it means P1 minus P2 is between 0.0828 and 0.1178. As you can see, H0 says P1 minus P2 is equal to 0, and 0 is nowhere to be found. So what do? Same result. It so happened to be the same result. Sometimes it may not be, I told you, because we are not using P bar, Q bar here. We are using P1 hat and Q1 hat and P2 hat and Q2 hat. But we get to the same result, meaning what? Reject H0. And the rest, we write it again.
The confidence interval limits do not contain zero, suggesting that there is a significant difference between the two proportions. The confidence interval suggests that the value of P1 is greater than the value of P2, so there appears to be sufficient evidence to warrant rejection of the claim that Connecticut and New York have the same proportion of cars with rear license plates only.
What I want to make sure everybody understands, two things. Number one, the claim can be either H0 and H1. If you're the researcher, you make a decision. If you want H1 always to, you set up your question such that H1 is always the claim, number one. Number two, the way you write your interpretation, there is or there is not sufficient evidence to support the claim. I am giving you different versions on purpose, because if you come across a different text, you're doing some research or you're studying another course that relies on this and the wording is slightly different, so be it. You are exposed to various methods. But the best and easiest way is very simple. There is sufficient evidence to support the claim and you do the writing. Or there is not sufficient evidence to support the claim, that and you do the writing from the question. That would be the fastest and easiest way to do the writing properly, and you never go wrong with that. So having said that, what if we want to do the confidence interval using a TI? You go to stat, test, to proportion Z, and you plug in the info, and it gives you the answer. As you can see, we are right on the money. Let's go to the next example.
A researcher found that 12 out of 34 inner-city nursing homes had a flu vaccination rate of less than 80%, while 17 out of 24 countryside nursing homes had a flu vaccination rate of less than 80%. At alpha equals 0.05, test the claim that there is no difference in the proportions of the two nursing homes with a flu vaccination rate of less than 80%.
Number one, we are dealing with proportion. Number two, we should be able to write the given. Inner city, 12 out of 34. X sub 1 is 12, N sub 1 is 34. And then 17 out of 24, that's X sub 2 and N sub 2. And they had a flu vaccination rate of less than 80%. And we are looking at, of course, alpha of 0.05 and P1 and P2 of 0.8. So with that being the case, let's start looking at the test of hypothesis, which means we start with H0 and H1. We are saying that P1 minus P2 equals 0. P1 minus P2 is not equal to 0. Test the claim that there is no difference. So that gives us the following. It is the equality versus not equality, not less than, not greater than, and it makes it a two-tailed test. There is no difference. If there is no difference, what does it mean? P1 minus P2 equals 0 is the claim. So again, the claim doesn't have to be H1. Let's see what happens now. We do a calculation. To do the calculation for test statistic, take a look at the top, Z. And we have to calculate P bar, which means we need a couple of things. We need, for test statistic, for the numerator, we need P1 hat and P2 hat. So X sub 1 over N sub 1, X sub 2 over N sub 2. For P bar, we need X sub 1 plus X sub 2 over N sub 1 plus N sub 2. So we have to calculate those first. And I'm assuming everybody can do that. Again, it's tedious. It takes a little bit of time. You must do that. But that would be really the main difference between this and previous sections. Having said that, we are done with that. We just plug it into the test statistic Z equals P1 hat minus P2 hat over P bar Q bar over square root of P bar Q bar over N1 plus P bar Q bar over N sub 2. And this is a calculation that needs to be done. Whether you put it in this format or the other one makes no difference. I hope you remember the other format that I put. We pull out P bar, Q bar by factor. Either way, we end up with negative 2.7 as our test statistic. It's a two-tailed test. Alpha is 0.05, so we have the same 1.96 and negative 1.96 as our critical values from the table, the Z table. Now we do the same thing. We do the drawing, which means you have a graph, you show 1.96 and negative 1.96, and you compare negative 2.7 to see where it ends up. Is it in a tail or somewhere in between? Negative 2.7 puts us way into the left rejection region as follows. So negative 2.7. If you look at this one, what do? What is your decision? Simply put, reject H0. When you're rejecting H0, that means you're rejecting the claim because claim is part of H0. That means you're saying the claim is false, and then you do the rest.
Decision. A. Reject H of 0. B. Claim is false. C. There is not sufficient evidence to support the claim that there is no difference in the proportions of inner city and countryside nursing homes with a resident vaccination rate of less than 80%.
And of course, you can do calculated work. If you do the calculated work, what it gives you is the p-value. P-value is 0.00767 and the rest. What is that? Less than alpha. But you have to multiply this. Now, this you don't have to multiply by 2. But you have to multiply by 2 if you look up this area of to the left here of negative 2.7, you have to multiply by 2. But the calculator gives you the p-value. In any event, it is less than alpha of 0.05, and you have the same decision. The p-value equals 0.007. I'm going to round it, and that's less than alpha of 0.05. Therefore, reject H0, and then you do the writing. So it gives you exactly the same answer. We are going to look at the same question, but this time confidence interval is used. And I'm using that because it does have a different formula. Remember, we use P bar and Q bar for the test statistic, but we use P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2 under the radical form. We need to calculate the E. To calculate the E, we need P1 hat, Q1 hat, and P2 hat, and Q2 hat, and all of them have been calculated. By the way, of course, Q1 hat is 1 minus P1 hat. Everybody knows that. So now we're going to plug into the value for E. We have the same Z, 1.96, and it gives us the value of 0.24. We need to calculate this, and okay, granted, it takes a little bit of a time, but it's really not that big of it. We calculate that, we have it, and now we are going to add and subtract this from the difference of P1 hat minus P2 hat. So having said that, let's see what we end up with. This is how we do the math. And so now P1 minus P2 is between two negative values. 0 is not included. It actually, not only you reject H0, you can see that according to this, if P1 minus P2 is between two negative numbers, that means P1 must be less than P2. Okay? Again, according to this calculation. So 0 is not contained in the interval. The decision is to reject the null hypothesis of equality. If we were to do TI, this is what we end up with. Let's go to the next example. For this sample data, we're going to use a 0.05 significance level to test a claim that proportion of minority drivers stopped by the police is greater than the proportion of white drivers who are stopped. So according to this data, what is given, we are dealing with a binomial distribution. One group is N1 and X sub 1. One group is, and you can calculate the P1 hat. One group is N sub 2 and X sub 2. And we need to calculate P bar when we do the test of hypothesis. So why don't we do it right here? So when we go to the next page, we are ready to do the test of hypothesis. So this is the given information, P1 hat, P2 hat. By the way, Q1 hat is 1 minus P1 hat, and Q2 hat is 1 minus P2 hat, obviously, so that's not a big deal. And so with that being the case, we calculate everything that we need, so we are ready for the test of hypothesis of the next page. So let's do that. So this is the information that we have from the previous page, the given information, P bar, Q bar, and so on and so on. And so now H0 P1 equals to P2 and H1 P1 is larger than P2, and that is the claim that we are testing according to this question. Because of this, we are testing this claim. So that makes it a right tail test. You do the math by calculating test statistic, the formula in the top right. You just plug in, remember P1 hat and P2 hat were also given from the previous page. And so with that being the case, we have everything we need. We end up with 0.6422. And this is an alpha of 0.05, but it's a one-tail test. To find the critical value, all of alpha is on one side, specifically in the right tail. And so with that being the case, Z becomes positive 1.645. Where does this number 0.6422 belong? Here, it's on the left side. It's way into the non-rejection region. So according to this data, we failed to reject H0. And therefore, we don't reject H0, that means we reject H1, we reject the claim according to this becomes false.
Decision A, fail to reject H0. B, the claim is false. C, there is not sufficient evidence to support the claim that the proportion of minority drivers stopped by police is greater than that for white drivers. This does not mean that racial profiling has been disproved. The evidence might be strong enough with more data.
That's another, remember when you do this, you have to pay attention to a lot of factors. And one of them is the sample size, which really is important. With that being the case, let's go to the p-value and confidence interval method. The traditional method, it was just done. Going back to the concept of a p-value, you need the area to the right of test statistic. This is what you need. Test statistic was calculated as 0.6422. So the area to the right of it is the answer. And the reason we are using two decimals for the sake of a table, which is limited, we end up with the p-value of 0.2611, larger than alpha, and same result. Failed to reject the null hypothesis. So we will get to that when we want to do the confidence interval in a moment. But for now, test statistic results in a p-value of 0.2611, larger than alpha. Do not reject the null hypothesis. Again, some authors and some texts, they don't want you to write don't reject, fail to reject, which is actually more proper wording. I want you to know that. Fail to reject is much better. To come up with a confidence interval, you need the formula on the left side, P1 hat minus P2 hat plus minus E. P1 hat minus P2 hat, actually you have it when you calculated the test statistic. So all you have to calculate is the value of E. Simply plug in. And when you plug in, you end up with 0.0404. You're going to subtract and add this number to P1 hat minus P2 hat, and it results in the following. We did not reject H0. Same result here. Why is that? Because this contains 0. Same result, failed to reject the null hypothesis.